Good afternoon to everyone. My name is Aldo Puglisi, and I'm working for HUPAC Intermodal. We are intermodal operator, and I am the head of IT and digital. So in this short presentation, I would like to present you a small project we have done internally with two guys from SUPS University in Lugano. On AI and implementing, a prototype for an AI chatbot in our business. So if you can go to the next slide.
Yes.
So as Dimitri and Sergio were mentioning before, we have a huge amount of data in our business, in logistics, but also in intermodal. We have data from ADI, from GPS, from our internal systems. And of course, we have many ways already of exploiting it for our customer and also for our internal users. So the idea behind these projects was to create a small prototype to support our operations. So, for example, the train monitoring department to access real-time data about train running. About disruption, about delays. Unfortunately, sometimes we have delays in intermodal, so there is also a need to access to access this data. And so we try to implement this by implementing two theses with the SUPS University, as I said before, and to design and implement a prototype of an AI chatbot. Okay, if you can go to the next slide. So the current scenario today, of course, we have our platforms that is used by our internal users and also by our customers, where we are consolidating in a single place all data related to our business. So all business data or process about the train running, about booking from the customer, status of the train, irregularities, master data are in our HUPAC platform Wolf. Maybe most of you know it. In addition to that, as you know, we work also with our partners. We receive a big amount of documents, PDF, emails, API streams, images, and so on. And all this data, normally the strategy at HUPAC is to have a single place where we have everything. But as you know, in the supply chain, we have interaction with others, and we have also a big number of documents that our operational people use to manage our train. So if you go to the next slide, please. So the solution that we propose in this thesis is a prototype of AI chatbot where the users can submit requests in natural language, like ChatGPT and Gemini and all these tools, in Italian, English, and German. And the context was the train circulation, okay, and the train disruption, the irregularities that we can have on a specific train, wagon, or unit. The system automatically is able to detect so-called the user intent, so what the user wants to do and what he's asking for, is able to have a first model which determines the source of the request with the AI model behind, and then to return a structured answer in natural language. So what we implemented is a so-called RAG, Retrieval Augmented Generation, which is basically a kind of extension of generative AI and of an LLM model to answer a question according to our data. Okay, what I mean is, if you go to the next slide, without going too technical. Okay, so LLM, I guess that all of us, we know what's that. So, for example, ChatGPT or Gemini, they are large language model based on AI, which can recognize text, images, generate text, answers, and so on, and we can interact. And basically, they are, let's say, technically speaking, neural network architecture, which are very complex. What is a RAG? RAG basically is an extension where you add your, let me say in a simple word, your additional knowledge, as you can see on the scheme on the right, and you extend the large language model with your private data, okay? Because normally if you go on ChatGPT and ask something which is not in the data set it was trained, it normally cannot answer, okay? So what you do, you take your additional data in a secure way, you extend the LLM with your additional knowledge. And then this additional knowledge allow you to use the chatbot to query and to interact with your data in addition to the one of the chatbot, okay? Now, if you go to the next. Okay, advantages and challenges of this kind of approach, of this so-called AI RAG. Of course, by adding your private and additional data to the AI model, to the basic model, you can obviously interact in a different way with your data and have your users to improve the way they are accessing the data and simplify the work, which is also an important step, because as Serge was mentioning before, it's not only the matter of tool, but also how the skills of the people are changing with this kind of additional instruments. Then, of course, is the advantage of this kind of approach is that you can adapt the generalized AI LLM like ChatGPT or Gemini to your specific domain. So to know a little bit more about your domain. Obviously, there are challenges implementing these kind of tools. Okay, apart from cost, which is always a point to keep into consideration, and how you are covering that cost. But this model, like any other mathematical tool, strongly depend on the data quality. So obviously, the data quality, someone was mentioning before, but data quality in and out are, let me say, strongly connected. And you have, we realized it also in the implementation of the prototype, but we were almost sure also at the beginning that you have an important part of the data cleaning and preparation to make this kind of model, because they are, like any other model, very heavy dependent on the noise and affected by the noise which are available on the data. And then, okay, last but not least, the computational overhead, it's quite important. Okay, if you go to the next, please. Okay, some details about the solution. So what we have done, we took a small set of representative data from our HUPAC databases. And then this data set were including data about our train circulation, about irregularities, about disruptions, and they were also divided by language, German, English, and Italian, and distributed across different categories. So in a nutshell, what the user could query to the model is like a typical question like, when is the train expected to arrive? Where is the unit located at the moment? What the status of the traffic in the different line? How many dangerous goods are in the train? And how is the train currently traveling? So typical question that business people have on the data about intermodal traffic. Okay, it can be our internal people or our external people. Again, it was a prototype. There's nothing which has been installed in production for the moment. If you go to the next one. Okay, the overall concept, that's just a logical schema. So basically you have the user on the left, which can query the data. And then as you see on the vertical part, you have the different documents, which are, let's say, stored on a special database, which is called vector database. And they are then provided to the large language model, so that the large language model, when the user makes the query, is extended with the additional data, prepared in a specific form, and then it's creating and generating the response to the user. Okay, so as you can see on the top left side, there are two kind of, let me call it, data input. One is the document sources, which is the historical data that have been used to generate the model, and the other one is the intention API, which is detecting which kind of source has to be used to retrieve real-time data, real-time information. Because, for example, if the user is asking what was the problem on this unit, then you can use historical data, for example, analyzing the emails and the PDF and the data in the system. But if the user is asking for where is now the train XY, then the system must detect that the answer is about real-time data, and it has to query the GPS API, for example, that we have internally. So depending from the type of question, there is also a model, the prototype prevents also a model to detect the intent of the user, okay? Then if you can go to the next. Okay, just some examples. Okay, for example, that's just a generic example. The interaction with the chatbot for a unit irregularity. So, for example, the user asked what happened to the unit PV and so on, and then the system was providing some details, explaining that there was a problem in a specific place and the door was not completely secure, and then there was an inspector which was fixing the problem without discarding the wagon, and is also explaining that photo protocol and so on were collected. Okay, you can ask the same question in Italian, which is providing, maybe for some of you which don't know Italian, is providing a slightly different answer, because the system is always elaborating, as I show later. And then, okay, there is also an additional question to ask if the verifier, meaning the inspector, was involved. And as you can see in the first answer, on the third line, the system was mentioning something about the inspector, but this was a specific question to explain and to ask that the verifier was involved and he was fixing the problem. Okay, if you go to the next. Okay, now this is a chatbot interaction for a train irregularity. So what happened to a specific train 40009? And the system is explaining that there was a problem in Taolof, that there was some vandalism and so on. Then same question asked in German. And then the third question, give the as Beweise and so on, it basically was asking if there were some proof about what was happening in the irregularity, and the system is providing an answer explaining that there were some proof, and then finally in the fourth question, it was also asked explicitly if there were some videos, surveillance video about the problem, and the system was able to answer that some videos about the problem were identified. Okay, if you go to the next, please. Then that's also another example for interaction for a wagon regularity, where basically same question, what happened to the specific wagon, and then also asking not only the information about the wagon, but about the unit, the container which was loaded on the wagon. Because normally when we are looking for something, we are interested about the wagon, but also about the unit which was transported on it, okay? And then also the last question, asking what happened to the unit if the wagon was discarded, okay? Okay, last example, if you go to the next, which was okay. This is, for example, also interesting because you can see that is an example on another train. But for example, the second and the third question, they are the identical question. You see, do you have more details about the problem for the train? But as you can see, the system was answering in a different way, because basically on the main answer was there was a problem, lack of resources. Then the user asked, do you have more detail? And then he was providing pretty much the same answer. But then if you repeat again the question, he was providing more details. And it was also saying that there was, you can see it in the second line in the answer, there was an internet problem at the terminal XY. Okay, then on the last question, the user was asking, is the internet problem resolved? And then say, not yet, the internet service provider informed us that it will be solved not early than 12 of today. So which means that even if you try to, interact with the content, the model is somehow able to re-elaborate and provide you more data, because obviously is using the full power. In this case, we were using Gemini, the one from Google. It was using the full power and knowledge of Gemini plus our additional test data. Okay, if you go to the next slide. Okay, first evaluation of result. We were running the prototype on different LLM. One of them was Gemini 2.5 Flash, and then we were testing also with additional 8 open source. As you can see, the different LLM models which were used have different size, different parameters, which are normally the variable weight that the model uses, and then the context window, which means the tokens that the model uses. As you can see on the top right, obviously Gemini, which is also the paid version, was performing well, but there were some open source models that in this specific case, again, it's just a prototype, so it has to be checked more and more in the detail. They were performing with a good accuracy on different scenario. Blue and orange means the different scenario that we tested, and I don't want to give you to annoy you with all the details. And then also the evaluation of the result in the query itself, comparing how was the answer of the model versus the expected result, was also good. Again, on a limited data set. Okay. If you go to the next. Okay. Conclusion. We have done 2 theses, obviously connected each other on this retrieval augmented generation to implement AI chatbot. We were able to show some first results. Consider that the theses were 6-month theses done in parallel, which means 5 months design development and 1 month to write the thesis. So it was quite in a short time. And it was able in the different prototypes to implement the ingestion, the vector storage, retrieval, and also the LLM and a small, very simple query interface. Obviously, results for the moment are satisfactory, but okay, we need to keep into consideration that it was a small model, a small prototype with small amount of data, and also latency, which was between 3 and 5 seconds when between the call of the user and the response is not really the best, but obviously it's a prototype, and is not acceptable in a production ready, let's say, environment, but for the first prototype, we were happy. Okay, possible future work would be to extend, let's say, the model on additional data types like images and so on, and eventually to extend what we have done for additional type of data sources on top of the train monitoring and operations. So this was the summary of what we have done. If you go to the next, if there is any question, we still have 3 minutes. Otherwise, thank you very much.
Yeah, thanks, Aldo, for providing a first experience with AI chatbot. It's amazing what you can do with a big Excel file. I retain that you have developed here a company-specific AI tool. That's exactly, I think, where we are going to go ahead. I've just this morning there was a news, I think, with an AI expert that this will be certainly the future. That there will be AI-specific, I think, application with, of course, private company data to improve, I think, this AI system. We are speaking a lot of data interoperability, but you have now mentioned data interactivity. So that's a new wording as well. So how the data can interact. So there we're coming back to the collaboration, and we shouldn't undermine the cost, because that's very often, I think, we have the impression cloud, digital, and so on is free of charge. But no, there's an additional cost, I think, that we have to take care of that. And I think you repeatedly, I think, said that, of course, the data quality is the must, I think, for that. Yeah. I have just one question. Did you, no, I think in the chat, there's one question, I think, that from Florian Wegenscheider. Can you say how many people worked on this, or how many people did you involve in this prototype? Yeah.
We have the 2 students of the university who did the thesis. Then we have one internal guy here in our IT team for the coordination. And then the professor, which was she was also helping and obviously following the students during the implementation of the thesis.
So before Serge can intervene, did the system reply to the question if Serge is satisfied with this service? Now, Serge, it's your turn.
No, I just thanks, Aldo. Nice sharing. It's just typical. You raise in the AI language, you call it a prompt. You raise a question to your AI, and yes, among those tools we are using every day, also in normal working, Gemini is one of the tools. You raise a prompt and you never get the same answer. You raise it 3 times, 4 times. Even if the database is not changed, you always get new answers. And that doesn't apply to background images like the one I have at the moment. It's also AI generated. But yeah, and then if the content is different, you can start asking yourselves, okay, this is why I said if a small mistake because of such interpretation errors doesn't hurt, fine. If it leads to decisions which really have serious consequences, then really don't let it go. But it's normal. It's just normal.
Then I have an additional question to you, Aldo. So where do you see further promising AI use cases for the HUPAC group? Do you see? Are you going to further develop it, or this chatbot, or you are going to analyze if other use cases can be also then implemented? Yeah.
No, we are okay. The chatbot is obviously one of the possible use cases. We are also analyzing additional use cases. Okay, one of them is how to improve. For example, we have internal development, software development, and we are also there having use cases. How do we support our developers in the development and of our internal applications? Because obviously, how to say, the point is that we believe that with this kind of tools, also in the development area, you can speed up the way we provide additional features to our customer. And then, okay, there are additional area. How do we improve the productivity? For example, like I'm not sure if Serge or Dimitri mentioned about the processing of some document which are coming internally to speed up some repetitive task, for example, of verifying or giving support to the user in the verification of document and data entry. And then obviously there are also additional things that we are thinking about, but they are still in a preliminary phase in the area of customer support or productivity. But is really for the time being still high level prototypes that we have to and ideas that we have still to develop.